Create a new third-person template. Let's create a new folder to keep it all organized. Import your animal into the project. Here I'm using Medu Trout from the marketplace. You can use any animal you like or need. Let's make some space. Inside our folder, create a new blueprint with AI controller as a parent. Ignore the fish blueprint. It will be replaced later. Open up the AI controller blueprint. Add AI perception stimuli source component. This will make our animal respond to stimuli sources. Add the hearing and sight senses to the senses array. You can leave the default settings for now. Compile and save. My recommendation is to compile and save very often, not to lose your work in case of a crash. Create a pawn class for your animal. You can create a character class blueprint if you need more control over the movement of your animal, or if you create a humanoid NPC. For most animals and for this tutorial, the pawn class will work just fine. Open the blueprint and search for AI controller. Here, select the controller we just made. This will ensure that the pawn will be controlled by our controller and not by the default one. Add a skeletal mesh and select your animal asset. In my case, the fish I've imported at the beginning of the video. If your animal asset pack comes with an animation blueprint, select it here. This is not mandatory, so if you don't have one, just skip this step. Compile and save your blueprint. Pull your new animal blueprint into the world and make sure it's above ground. Add a nav mesh bounds volume into the world. This will define the area that the animal can move. You can press P to enable debug mode. This will help you view the area covered by the volume. Resize it to create a space where the animal can move. Create a Blackboard blueprint. The Blackboard will keep track of all our variables needed for the behavior tree. Create a behavior tree blueprint. Here is where the animal behavior is defined. Create a new BT_task_blueprint base. This will contain simple logic or activities that the animal can execute. Name it BTT_roam. This will contain the logic for selecting a random point in the world that the animal can reach. This will be stored in a variable in the Blackboard blueprint so that the behavior tree can access it and use it later. Open up the behavior tree and create a selector. This will try executing all the nodes connected to it, and it will go to the next one only if the previous fails. From the selector, pull out and create a sequence node. This node executes everything connected to it in a sequence from left to right. Let's name it roam sequence. Open up BTT_roam and override the receive execute AI event. This node is executed every time the behavior tree reaches our task. Add a getRandomLocation in navigable radius node. This node requires an origin and a radius. Nav data will be provided by our nav mesh bounds volume automatically, and we don't need any filter for now. Add a getActorLocation node from the controlled pawn pin and plug it to origin pin. Set the radius to something like 1000. You can set it bigger or smaller depending on your needs. Add a new variable of type vector and name it selected location. Set the variable to the return value of the getRandomLocation node. Add a set Blackboard value as vector node. Before we can set the Blackboard value, we have to create the variable inside our Blackboard blueprint. Go to our behavior tree and select the Blackboard from the top right corner. Here, create a new variable of type vector and name it selected location. Save the Blackboard. Now, back into our task, from the key pin select Make Blackboard Key Selector. In the selected key name, write selected location. It has to be the same as the Blackboard variable we created. Now connect the value pin to the selected location pin. Add a Finish Execute node and set the success pin to true. This will notify the behavior tree that the task execution was successful. Add a branch node after the random location node and connect the return value to it. If a location was found, the true branch will set our variable to that location. If we cannot find a valid location to move to, we need to inform the behavior tree that the task failed. We do that on the false branch by adding another Finish Execute node with the success pin set to false. We want to set the variable only if we found a location and return true on Finish Execute. Back into our behavior tree, we can now add the task to the sequence node. Also, add a Move to Task and set the Blackboard key to selected location variable. You can find this setting under Advanced section in the Task Properties. Also, I recommend adding a wait task of 0.5 seconds as a buffer between any task that sets a Blackboard variable and a task that uses that variable. Before we can test it, we have to tell the controller we created to execute our behavior tree. So let's open up our AI controller blueprint. Add a Run Behavior Tree node from Begin Play event and select our behavior tree. Compile and save. Now we can test our code. It seems that our fish refuses to move. You can press single quote key to debug the system. We can see the branch executing in our behavior tree and the variable being set on the blackboard, but the fish is not moving. Let's find out why. The AI controller seems okay. Let's check the fish blueprint. While we are here, let's change the auto-possess AI to placed in world or spawned. This is not the problem here, but it's a good practice to have it like this. It seems I forgot to add the movement component to the pawn. Let's add a floating movement component so it can move when instructed by the AI. This is a basic movement component. If you need something more advanced that can handle jumping, falling, or swimming, you have to create a character blueprint instead of pawn. Character blueprint comes with a movement component capable of handling more advanced movements and provides more control over the speeds and other parameters. Now the fish moves, but it moves a little too fast and doesn't rotate according to the movement direction. Let's lower the max speed, acceleration, and deceleration. That's better. Now let's fix the rotation. It seems that my fish is rotated 90 degrees on the z-axis. Let's fix that. Here I'm using the arrow just to double check the correct orientation. The arrow always points to the front direction of the actor, unless you rotate it on purpose. Now the fish is facing the right direction. This is the initial setup and our first simple AI task. In the next episode, we will extend the behavior and add more tasks like searching for food and eating. We will learn how to use decorators and conditional behavior, so stay tuned. Thank you for watching. And don't forget to subscribe and hit the bell to make sure you won't miss our next episode. Please leave any questions or recommendations in the comments section below.